Selamat sore Bapak Ibu semuanya.
Sore, Prof. Jarot.
Selamat sore Pak. Gimana kabar?
Baik, Pak.
Ini di sini hujan lebat.
Iya, baru pulang.
Oh, baru pulang?
Iya.
Selamat sore Pak. Selamat sore Pak. Kabar?
Baik, Pak.
Ini apa? Kita tamu istimewa nih dari Rusia ini. Februari.
Selamat sore Pak Jarot.
Gimana kabar? Udah dapat penempatan belum? Brin?
Belum,
Oh,
belum Pak.
Masih menunggu-nunggu ya?
Masih menunggu Pak.
Iya, ditunggu aja. Ditempatkan di mana aja kan oke kan?
Insya Allah, tapi kalau bisa di
Insya
Bandung
Allah.
aja Pak.
Insya Allah kalau
Nggak mau
bisa di Bandung.
pensiun.
Masih lama tuh?
Ya 2 tahun.
2 tahun. Ya, kita tunggu aja. Ini ada Pak Ahmad Suntoro. Gimana Pak Ahmad Suntoro? Nggak ada ini ya, utamanya ya Pranata Humas ya. Bu Ari ya.
Maksudnya nggak ada utamanya gimana Pak?
Pranata Humas utama masih Madya ya, Pol ya, mentoknya.
Oh, saya bukan Ranata Humas Pak.
Oh, sekarang apa? Pranuk ya?
Masih Peranuk.
Oh,
Peranuk
Humas.
yang mau ke PTN belum jadi-jadi.
Pak Jarot, selamat sore, Prof.
Utama, gimana?
Ya,
Tetap sehat?
Prof. Alhamdulillah.
Oh,
Prof masih ingat nggak buku dapat nggak?
gimana?
Punya Pak Gatot dapat nggak?
Saya udah nanya Pak Gatot nggak ada rupanya. Saya nggak.
Oh, nggak ada.
Pak.
Laris manis.
Lupa
Ya udah,
saya.
nggak apa-apa.
Ya, waktu itu saya nanya ke kakak saya, ada buku ini nggak? Ini nggak ada, aku nggak punya. Beliau sekarang jadi apa ya namanya? Karena sestama udah selesai, udah usia 60, jadi staf khusus mungkin ya.
Iya.
Di
Iya.
Kemenpora.
Ya, makasih Pak.
Ya.
Pak, tamu kita ini orang Rusia, ngomong Rusia apa ngomong Indonesia?
Ya, sekarang apa ya? Dikuasai bahasa Inggris.
Iya. Ya.
Tapi Rusia adalah pemain utama di bidang energi nuklir karena ekspornya luar biasa. Ini Pak Egor udah masuk ini.
Ya. Terus itunya Pak, apa itu uraniumnya dulu kan banyak yang keluar nggak tentu rimbanya itu Pak. Ya waktu bubaran itu kan.
Ya, USSR, Uni Soviet.
Ya waktu acara bubaran itu, saya sempat juga dihubungin sama mereka.
Oh.
Wah, saya bilang saya nggak ngerti itu, ilmunya belum dapat. Tawarin murah-murah katanya. Saya bilang sorry lah, saya ilmunya belum nyampe ke sana.
Enggak Pak, utama itu ilmunya banyak.
Ya ini kan baru belajar nih sama Pak Prof. Mudah-mudahan dalam waktu dekat udah bisa lah.
Ini udah ada Pak Susilo.
Oh, Pak Ketua udah datang ya?
Ya Pak Ketua ini pasti di Jakarta. Saya ramal sudah ada di Jakarta. Ya Pak Susilo ya.
Belum tuh kelihatan.
Oh, belum kelihatan.
Belum.
Tapi posisinya sudah di Jakarta.
Oh, ada tuh Pak Ketua.
Ya, baik.
Apa kabar?
Alhamdulillah, baik.
Alhamdulillah, alhamdulillah. Pak Agus Wahid juga udah kelihatan dari fotonya.
Siap Bapak.
Apa kabar Pak Agus?
Alhamdulillah baik-baik saja.
Sehat ya Pak, alhamdulillah Pak.
Semoga...
Saudara saya ini Utomo, tapi bukan utama Utomo.
Semoga semuanya pada sehat semua Pak.
Amin.
Ya,
dalam
Pak.
lindungan Allah SWT.
Siap Pak, itu doa itu yang kita tunggu selalu Pak.
Dan karena kegiatan panjenengan semua ini kan mencerdaskan kehidupan bangsa.
Wah, moga-moga bermanfaat untuk semuanya.
Kegiatan kita ini kadang aneh-aneh Pak. Saya itu kan ngurusin singkong Pak. Belakangan ini dari mana-mana permintaan tepung tapioka itu rame gitu. Yang dulunya nggak rame, sekarang rame.
Itu berkah pandemi itu Pak.
Iya. Jadi dari Tiongkok itu, dari China itu, wow, permintaannya deres banget. Dan kita nggak bisa ladenin sementara.
Ya.
Makanya
malah jadi laris kan dagangannya Pak Utama.
Ya Pak, Pak itu kan ada masyarakat singkong Indonesia, ada industrinya, ada pabrik makanannya dan segala macam.
Ya, ini
Dan ya.
Pak Igor udah masuk sepertinya.
itu Pak Dubes RI untuk Australia Pak Tantowi Yahya itu juga berburu singkong loh Pak.
Oh.
New Zealand Pak, New Zealand.
New Zealand ya, sorry New Zealand ya benar.
Ya.
Sudah nembus
Iya,
ke sana Pak?
Kenapa Pak?
Sudah nembus ke sana.
Oh enggak Pak, New Zealand itu kalau dia butuh singkong segar, dia dapatnya dari pulau-pulau Pasifik itu Pak.
Oh gitu.
Iya, dan mereka kan kalau jualan kemana-mana antara mereka kan free tag, free service segala macam.
Oh iya.
Kalau kita nggak bisa, nggak
Ya,
harganya nggak cocok.
Ya, waktu saya ada kegiatan webinar sama Pak Tantowi Yahya itu, kemudian diinformasikan bahwa New Zealand butuh singkong banyak.
Iya, tapi harganya nggak cocok Pak, jauh Pak.
Oh gitu Pak ya.
Ya,
Terlalu
jadi,
murah Pak ya.
kalau kita 1 kilo di sini 1.000, di Sydney itu 1 kilonya 50.000. Kalau di New Zealand itu 70.000, tapi sudah bersih. Jadi bedanya jauh sekali. Tapi prosesnya itu yang mahal Pak.
Iya.
Ya prosesnya mahal dan hitung-hitung ya nggak cocok lah.
Kosnya terlalu tinggi Pak ya.
Kosnya tinggi dan permintaannya kan tidak regularly continue gitu Pak.
Oke.
Ada musim-musimnya.
Putus-putus berarti Pak.
Putus-putus ya.
Yeah. Hello Igor. How are you Igor? Can you hear me?
Bang Igor.
Hello, yes, we can hear you.
Okay.
Can you hear us?
Yes, we can hear you. It's okay. Thank you. Yeah. Can you open your camera?
Yes.
Direndam sama jeruk.
Oh.
Iya, jeruk.
Okay.
Ini saya lagi sama tamu dari Kementerian Desa
Oh, okay.
Di
So
Pantai
you are
Demilir.
here. Thank you. It's very clear. Your presentation. It's already open. Okay. Okay.
Jadi kayak dia itu baunya tuh nggak terlalu.
Acara nuklir. Nuklir untuk emisi zero.
Okay. I will, because I will open this webinar, I will close your Presentation? Oke. Udah jam ini ya? Oke. Saya akan memute-kan Bapak Ibu semuanya, seluruh peserta, sehingga mempermudah kita untuk mendengarkan dari narasumber. Ya. Good afternoon, good day, everyone, participant of this webinar. Today we have a very special guest from Russia, Mr. Igor, would like to talk about the contribution of nuclear energy for the future net zero emission in Russia. Russia will have a target for the net zero emission on 2060, just like Indonesia. Indonesia have a target also on 2060, and according to the Ministry of Energy and Mineral Resources of Indonesia, we will have the nuclear power plant on 2045 or maybe 2049, and it will reach 35 gigawatt of nuclear power plant on 2060. So I think it's very interesting to know about this progress, and also it is good also to know about the situation in Russia. Russia is a very interesting place. It is interesting country to know well about the target of net zero emission. Because why? Because they are, I can say, the superpower of energy. There are abundance of oil, natural gas, and some other resources. So I think it is interesting if we know well their roadmap, their timetable, about these activities on net zero emission, and what can we do, what the nuclear energy roles with this kind of roadmap. But before that, I would like to ask Dr. Susilo Widodo, as the chairman of Indonesian Nuclear Society, to give the opening speech. Please, Pak Susilo.
Well, thank you very much, Prof. Jarod. Shall I speak in English or Indonesian?
This is international webinar. You should say give speech in English.
Okay, thank you very much, Pak Jarod. Good afternoon, everyone in Indonesia, and good evening for Mr. Igor Sagachev in Russia. Greeting from Jakarta. At this time, I am in Jakarta, not in Yogyakarta, but now it's a little bit hard rain in my house. And salam sehat, good health for everyone here. At this time, we have a webinar. I think the webinar in about 50, Pak Jarod, 51st or 51 of
50th.
Yeah. 50 in this year, and so today we have opportunity to hear from our distinguished speaker from Russia, and concerning the trending topic recently about the zero emission of carbon, and means that we have to try to overcome with other energy resources like new and renewable energy become the most candidate to overcome the commitment for the zero emission in 2060 it feels still rather long time, but I believe that from the planning point of view, this will have to make a decision soon, whether because we need the strategy, the good strategy to reach the zero emission relay in 2060. Means that we should calculate how long earlier, what time, how many years earlier than 2060 should be ready to start, for example, to introduce other resource. In this case, we expect that nuclear is one amongst the possible option to fulfill the need of energy, electricity, to fulfill our commitment for zero emission. Then, I think yes, I will not to talk so much here because I hope that we will get more time for our distinguished speaker, Mr. Erkon, and we will happy to hear from Mr. Egor Sakachev about the Russians planning to fulfill the commitment of the zero emission, and we, Indonesia, will can make learn how so big country like Russia will have a plan on this issue. Okay, Pak Jarod, thank you very much, and once again, have a nice webinar. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Susilo. Thank you Pak Susilo Widodo as the chairman of Indonesian Nuclear Society or HIMNI. So as he said that this is our 50th webinars. It's mean totally during 2 years we have 82 webinars. Every week we held the webinars, mostly every Thursday. So various activity we did, but not only on the webinar. We conduct also the international conference, the training, and others. So before we begin and give the floor to Egor, I would like to show a short video clip about the Indonesian Nuclear Society. And we expect and hope that everyone would like to submit to be the member of the Indonesian Nuclear Society or HIMNI. Okay. Before we begin, I would like to read the CV of Mr. Egor Sakachev. So Egor Sakachev, he has a, well, I think he is very younger than me. In January, I will be 59. I think he less than 30, I think. He has a work experience of, from this year as an international activity specialist in Rosatom Technical Academy. And before that, he worked for the personnel training specialist at the same organization. And his educational background, he received the master from St. Petersburg State University Institute of Earth Science and Environmental Management Program. And he received also the bachelor degree from Moscow State Institute of International Relations, Faculty of Applied Economic and Commerce, International Economic and Environmental Program. I think he has a educational background that very interesting about the economic, about the commerce, international relation, I think the environment management program. So I think his background and his experience, I expect he will deliver many things about the Russia and the capability of Russia on the roadmap of the net zero emission target. Please, Igor.
Thank you, Jarrod, for introducing me. And now I'm ready to start the presentation about, as you mentioned, the topic of nuclear energy and Russia, and about the impact of nuclear energy on the decarbonization of the economy. Can you hear me?
Yes.
And you can also see the presentation, right?
Yes, yes, it's clear.
Great. Then we will start. So let's start with some basic background on the climate change issue. Climate change itself is some changes in the climate parameters. Such parameters as the temperature, such parameters as the movement of air masses, the acid level in the oceans, and so on. Such changes happen every time during the whole history of the Earth. But now we are concerned with the modern climate change. And the modern climate change is unprecedented. It means that the pace and the speed of such changes, the speed of changes in the temperature or in some other parameters is extremely high. It is higher than the humanity has ever traced before. This is why this problem is burning, and the politicians, the economists, take some actions to combat this modern climate change. Climate change leads to several bad consequences. It includes the increase of frequency of natural disasters, such disasters as floodings, as hurricanes, as heat waves. They happen more often and they cause more damage than they used to be. There are also problems with desertification. It means that we have less and less forest and we have more dry areas where agriculture and living of people is very hard. And there are also problems with the migration of species, also migration of diseases, spread of diseases. So some animals, birds, mammals, they try to find new places with the most comfortable climate conditions for them. And when they migrate, they may also spread some diseases, some infectious diseases. And this is also one of the key problems of the tropical areas on the Earth. One of the main organizations analyzing the climate change is IPCC, Intergovernmental Panel on Climate Change. They analyze hundreds and thousands of scientific reports on climate change, and they publish their reports on this topic. A few months ago, they published the first part of their 6th report. And here in this report, we may find a quote that it is unequivocal that human influence has warmed the atmosphere, ocean, and land. Widespread and rapid changes in the atmosphere, ocean, cryosphere, and biosphere have occurred. So there is enough evidence that it is the human which is responsible for the current climate problems. One of the key change is the global warming. It is the increase in global surface temperature. It was noticed that for the last 150 years, so after the Industrial Revolution and development of steam engines, the global surface temperature has increased by more than 1 degree Celsius. And the scientists also analyzed their previous data for the previous 2,000 years, and due to some advances in science, scientists may also understand the temperature and the concentration of some gases even 100,000 years ago. So they analyzed all this data and they found this unprecedented change, this unprecedented growth in global surface temperature, which has never happened before. Another important organization in the field of analyzing climate change and the climate is World Meteorological Organization, WMO. They also prepare some reports and some findings on the climate change. There are dozens of parameters. One of them is changes in sea level. So for the last 30 years, the global sea level has increased by almost 100 millimeters, and it continues to grow at the annual average speed of 3.3 millimeters every year. This is an important topic, and this might be the problem for many island countries, as they would have less and less land. So what are the reasons of climate change? Basically, we can determine natural and anthropogenic reasons. Natural reasons happened and still happen all the time. They include some changes in the Earth rotations, so the Earth rotates not also around the Sun, and this rotation, the lengths between the Earth and the Sun differ, and there are several cycles which explain why it differs. For example, one of the cycles lasts for 41,000 years. There are also changes in solar activity, so the Sun may have more energy, more thermal radiation to the Earth, and less thermal radiation. And there are also processes inside the Earth, inside our core, which often cause some volcanic eruptions. For example, one of the most severe volcanic eruptions happened almost 200 years ago, and that eruption affected the climate. But for now, there is evidence that the anthropogenic factors are the most important. They mostly include emissions of greenhouse gases. So basically, there are a lot of greenhouse gases, and the most important one is water vapor. However, the concentration of water vapor remains almost the same. This is because more than 70% of the Earth's surface is covered by water, is covered by our oceans. So it is extremely hard for humanity to affect the concentration of water vapor in the atmosphere. However, people do affect the concentration of other greenhouse gases, mainly carbon dioxide and methane. Other anthropogenic factors include changes in land use and also the problems of deforestation. So people cut trees and they create more and more farms and other agricultural lands. And such lands also affect the climate and affect the emissions of greenhouse gases. So I have mentioned the importance of carbon dioxide and the importance of methane, and there are a lot of studies proving that the concentration of these gases increases, and this increase goes by almost energy sector. Here on this picture on the right, you can see the increase in concentration of carbon dioxide. For the last 35 years, the concentration of carbon dioxide has increased by more than 25%. And we also see the rise in the concentration of methane, the second most important greenhouse gas. So the humanity noticed such changes and back to the 70s and back to the 80s. So by the 90s, politicians and scientists agreed that we need some international agreements concerning this climate change problem. So 30 years ago, the Unified Nations Framework Convention on Climate Change was signed. This convention sets some targets, sets some aims for all countries which signed this convention, and almost all countries on the world signed it. Since 1995, politicians and parties of this convention organize annual events. They are called COP, Conference of the Parties. They are conducted every year. And during these conferences, new agreements, new amendments are added to the convention. Here are the most important ones. So in 1997, the Kyoto Protocol was added to this Convention on Climate Change. Also, back to 2015, the Paris Agreement was signed and ratified by most of the countries. And the key objective of the Paris Agreement is to halt the increase of the global surface temperature, and it should not exceed 2 degrees Celsius in 2100. Actually, by now, it is also has exceeded the pre-industrial levels by 1.1 degrees Celsius. So politicians agree that we need more urgent actions to meet these climate goals. The last conference ended just 2 weeks ago in Glasgow, and the parties agreed on Glasgow Climate Pact. It includes some more advances in tackling climate change. There are agreements on controlling the methane emissions. There are agreements on protecting the forests. And there is also an agreement that the coal, which is one of the main polluter, coal industry, coal energy is one of the main polluters of the atmosphere. And we need cleaner technologies for coal generation. So I have mentioned that the energy sector is one of the key contributor to greenhouse gases emissions. And this is also illustrated by IAEA, International Atomic Energy Agency. They show that the share of energy in greenhouse gas emissions currently is approximately 65%. And most of these emissions are attributed to carbon dioxide and methane, as you can see in this graph. So we see that there are changes in our climate. we understand that these changes are caused by greenhouse gases emissions and most importantly by carbon dioxide emissions. So this is why in international relations, in some agreements, we mostly discuss carbon dioxide. And we also see that it is the energy sector which is responsible for most of these emissions. So we should prioritize changes in the energy sector. Here is the graph prepared by International Energy Agency. It shows which energy sources contribute more to the carbon dioxide emissions. It is clearly seen that the coal is on the top of this graph, followed by oil, which is currently mostly used for transportation, not for electricity generation, and by cleaner energy gas. And all the other energy sources, well, they're at the very bottom. They contribute to the least amount of carbon dioxide emissions. So we see that there are some problems with fossil fuels, with coal, with oil, with natural gases. And so what are the alternatives? There are numerous, and nuclear energy is one of the best options for decarbonizing the economy, for reducing carbon dioxide emissions, while maintaining the energy production. This graph is prepared by IPCC, and it analyzes carbon dioxide emissions throughout the entire life cycle of different power plants. So, and the nuclear power plants are one of the, at the bottom of this graph, they emit one of the least amount of carbon dioxide per kilowatt hour of energy generated. This is achieved due to several reasons. First, nuclear power plant has zero direct emissions. So there are no processes inside the reactor which lead to emissions of greenhouse gases. And the most of carbon dioxide emissions here are caused by other parts of nuclear energy life cycle, which include extraction of raw materials, fabrication of fuel, transportation operations, for example, transporting that fuel, and also by construction works. So these elements contribute to the carbon dioxide emissions for the whole life cycle of nuclear power plant. This is why they are extremely low compared to coal, natural gas, or oil power plants. What are the other advantages of nuclear energy? Well, one of the key advantages of nuclear energy compared to other renewable sources is that nuclear energy provides stable generation of electricity. It isn't affected by the time of the day, whether it's day or night. It isn't affected by the wind speed or the wind direction. So nuclear power plants mostly operate at the maximum capacity factor. They produce almost all energy they can, as well as some fossil fuels power plants such as natural gas and coal. But there are some, of course, problems with renewable energy sources. With solar, yeah, it is very clean, while the electricity generation of solar power plants is unstable. There are even more changes in the generation of electricity by wind power plants. And actually even hydroelectric power plants have some problems with the stability of their electricity generation. There was a case in Brazil when there was several years of drought. So there were dry weather and there were less water in their rivers and their reservoirs. And that is why the electricity generation by hydroelectric power plants also dropped during this year. And again, this is not the case for nuclear energy and for some other energy sources. The other important advantage is the land demands for nuclear power plants. There are several studies analyzing how much land we need to for the same installed capacity. And there is an estimation that a nuclear power plant of the installed capacity of 1,000 megawatts requires almost 200 less land compared to wind farms of the same capacity, while and also almost 50 or 60 times less land as solar power plants. If there is a scarcity of land for building a power plant, an NPP would be the better option because it could provide more energy from one piece of land. And the next advantage is that the cost of electricity generated by nuclear power plants is also comparatively low. This graph, this chart prepared jointly by International Energy Agency and Nuclear Energy Agency, analyzes costs of electricity from different energy sources. And nuclear, again, is pictured as one of the cheapest sources of energy. While, as we can see in this graph, solar panels, solar photovoltaics, it remains one of the most expensive ones. So by now we know the impact of climate change, the reasons of climate change. We also know the role of energy sector and the advantages of nuclear energy. So now let's analyze features of Russian strategy on the low carbon development. As you know, and as it was previously mentioned, Russia tries to reach carbon neutrality by 2060, as well as Indonesia. This will be achieved by decreasing our greenhouse gases emissions by 60% compared to 2019 levels by 2050. So you can see that Russia doesn't plan to decrease its greenhouse gases emissions by 100%. So this is the question: how then we can achieve carbon neutrality? The answer is that we will also develop some measures and some technologies for absorption of greenhouse gases and for absorption of carbon dioxide, for absorption and for capturing carbon dioxide from the air, from the atmosphere. And there are ways how to do this. And one of the best ways is forests. Trees can consume, they can store huge amount of carbon dioxide. So Russia also develops measures, allocates some money for forest protection, for forests development programs, as forests and also some other natural ecosystems are also important in dealing with climate change. Other measures include the development of low carbon energy sources. These include nuclear energy and other renewable energy sources. There are plans that currently in Russia, nuclear energy accounts for 20% of our electricity generation. And now there are plans that this share should be increased to 25%. So 25% of our electricity must be generated at nuclear power plants by 2060. It means that we need to build some more nuclear power plants in Russia. But there are also plans for the development of other renewable sources like wind energy, solar energy, hydro energy, and even the development of hydrogen energy. What about other renewable energy sources of wind and solar? There are plans that they should consist approximately 12% of our electricity generation. Now they are just, their share is just 1%. So a huge increase in wind energy and in solar energy is expected. The excess energy produced by such renewable energy sources, by solar panels, and also by nuclear power plants may be used for the production of hydrogen. Hydrogen may be good for decarbonizing some specific economic activities. Currently, hydrogen is widely used for agriculture, for producing some fertilizers. And if we generate a green hydrogen produced by renewable energy sources, then again, our total emissions would be lower. Here is the chart of Russian energy sector. It shows which energy source, each energy source and its share in electricity generation. It is seen that the natural gas is the basis of our electricity generation. Natural gas contributes to approximately 40% of electricity generated, while coal, nuclear, and hydro power each has its share of approximately 18, 19, 20%. All other possible energy sources like oil and renewables, including geothermal energy, constitute less than 2%. And as we discussed before, there are plans that the share of such low carbon energy sources of renewable energy sources should be increased to 12.5%. What is the case of Indonesia? In Indonesia, in your country, the situation is a bit different. Coal is the dominant source of energy, and it is can be seen that the share of coal increases extremely fast, followed by natural gas, hydropower, and also geothermal energy. In Russia, geothermal energy is not so important because the best locations for geothermal power plants are located in very remote areas where there is no population and no human activities. But for your country, it might be the better solution for decarbonizing the economy. But as well as some other renewable energy sources, geothermal energy has some drawbacks. It has relatively small capacity compared to nuclear power plants. Again, for the same installed capacity, we need more space attributed to geothermal power plants than for nuclear power plants. And as we have discussed in the beginning of this webinar, coal is one of the key contributors to climate change and to greenhouse gases emissions. So this would be better to develop more cleaner and more stable energy sources like nuclear power plants. Rosatom follows these goals, and Rosatom now not only develops nuclear energy, but Rosatom also develops wind energy. It was mentioned several times that there is like a green square. It's a combination of nuclear, hydropower, solar power, and wind power. So they all are one of the best examples of low carbon energy. And if these energy sources work together, if they operate together, they can provide us with stable and at the same time clean energy. That might be the future of our energy system at the global scale. So this is the end of my talk. I hope you enjoyed it, and thank you for attention. I'm open for your questions.
Okay, thank you very much, Igor. It's very interesting. You show us with the actual data about the climate change is real. So about the increase of the temperatures of the Earth surface. And also you show us the advantage of nuclear energy and this. And also very interesting to know well about the comparison about the Russia and Indonesia on the energy. I have a question for you, Igor. Before
I looked through the chat, but
don't worry. I will read it in English.
I can
don't worry.
see messages.
Yeah.
In
okay.
English. So
I will translate into English.
if you have any questions, please ask them right now.
Okay.
Write in the chat.
Okay. Maybe some of them also would like to ask you directly when they raise their hands. My question is first. You have well, number one, the natural gas reserve in the world, and number two, coal reserve in the world. In the position of natural gas on the climate change.
Sorry, one moment, I can't hear you.
Okay. I will speak again. Can you hear me? Hello?
Okay, I can hear you now.
Okay, you can hear me. As far as we know, that Russia is rich on the energy resources, number one on natural gas. So the interesting is when you have a net zero emission target on 2060, where is the position of natural gas? Are you still you still have this year more than 20%, I think, for the natural gas. How about in 2060? Can you hear me?
Thank you for question.
Okay.
Yeah, the share of natural gas is expected to be almost the same as it is right now. So approximately 40 or 35%. And new renewable energy sources like wind and solar panel, and also the increase in nuclear power should replace coal generation. Mostly they are for reducing coal generation. And for natural gas, there are also technologies for, they are called CCUS, carbon capture, utilization, and storage. And it is expected that most of the gas power plants would be equipped with such technologies, so they would capture carbon dioxide and other gases at the same site, at the site of this power plant.
Okay. Well, it means that for the net zero emission, you will depend on the nuclear, hydro, and still natural gas, isn't it?
Yes,
and renewable energy, of course.
and also on carbon capture and utilization technology. And for forests, we also develop our programs for forests for carbon dioxide capturing.
Okay, so it means you would like to modify the coal power plant well, with the advanced technology on the carbon capture storage or something like that, is it? Okay, and we are in Indonesia right now on the trend to utilize the coal for other purposes, like to replace the liquefied natural gas. Is there any the same or similar program on that to use the coal not for the not the power plant, for the other purposes, for the I think for the consumer use?
Coal is also used for steel production purposes and for some other industrial process where the coal is the best solution. Yes.
Okay.
There are those two.
Okay, thank you. If you have any, I would like to ask the audience, if you have any question directly want to ask Igor about the Russian situation, please raise your hand. Or maybe I would like to read the question from the audience. First, from Mr. Dasrianto. How about the energy mix situation, the projection on 2050 in Russia? Maybe the percentage of nuclear, how many percent of the natural gas and other sources. And the second question, do you will implement the carbon tax?
Okay, so for energy mix, there will be some changes. So nuclear energy will increase from 20 to 25%. Natural gas, as I mentioned, would remain almost the same. And for new renewable energy sources, for small hydro power plants, for wind and for solar, they should increase to 12%, replacing the coal generation.
Okay.
And for carbon taxes, yeah, this is an important topic in our energy sector for our businesses and for our politicians. There are some laws are developed concerning these carbon regulations, but mainly for the next few years, Russia will follow the international trend and mainly the European trend on carbon taxes. So the European Union wants to apply some taxes on several products. So if there are a lot of emissions connected with these products, and in order to reduce such payments, in order to reduce such taxes, our companies are interested in developing low carbon energy sources to reduce such payments. But yes, there will be developed some taxes as well in Russia.
Okay, thank you very much. And there is one question from Mr. Arshad. He asked about the nuclear energy, about the fuel. Maybe I will translate into more simple sentence. How can you get the uranium from where? Or maybe Russia already exploit the uranium from your own land, or maybe import from others? Do you import the uranium from outside, or you exploit by yourself from the Russian land area?
Well, there are some deposits in Russia with uranium ore, and yeah, we exploit such deposits, and we also import uranium ore from other countries, mainly from Kazakhstan.
Oh, mainly from Kazakhstan.
Our own uranium ore and foreign uranium ore.
Okay, so it's very interesting because some Indonesians always ask about when we develop the nuclear energy. Some people ask, where will we get that uranium? Can we exploit our uranium in maybe in a certain island in Kalimantan or other? When I said no, we will import it. It's okay to import the uranium from outside because it is very normal business. Well, your answer show us that even Russia import the uranium from Kazakhstan. Okay, thank you. How about the thorium? Some people would like to ask about is there any progress on thorium power plant in Russia?
Well, thorium is not the top priority for our nuclear industry, as Russia mainly advances in closed fuel cycle. So now there are programs and even special nuclear power plants are built, which will use spent nuclear fuel from current nuclear power plants. They will reproduce this fuel, and this fuel may be used again. So there are some programs for developing new types of nuclear fuel and for reprocessing existing spent nuclear fuels. So this is why thorium is not.
Okay, thank you. I think this is also very interesting for the audience, that the Russia, they apply the closed fuel cycle. So it means the spent nuclear fuel that after they use inside the reactor, they will reprocess again to use again the uranium and plutonium to put inside the reactors for the operations. This is maybe different with us. Maybe our policy in Indonesia is open cycle for the nuclear energy program. So the government say that after we use inside the reactor, the spent fuel can be defined as high-level radioactive waste, should be stored and then in the future to be disposed in a certain location. So this is the answer from Pak Egor. He said that because the situation in Russia, they mainly use the closed fuel cycle. So maybe they are not focusing on the thorium or other alternative technology. Is that right, Egor?
Yeah.
Okay.
Yes.
Okay, thank you. This is a question from Zulkarnain. How much carbon dioxide emission can be reduced per year if we use 1 unit nuclear power plant? This is very...
I see. It's an interesting question. Unfortunately, I forgot the numbers, but for the whole Russian energy sector, there are estimates that all our nuclear power plants, we have 11 nuclear power plants, which generate almost 20% of our electricity. So all these nuclear power plants help us to reduce 100 million tons of carbon dioxide emissions. So if we would close such nuclear power plants and replace them by coal or by natural gas power plants, we would have more carbon dioxide emissions.
Okay, thank you, Igor. This is Mr. Arif Nurrahman who would like to ask you. Please, Pak Arif.
Thank you, sir. My name is Arif Nurrahman. I have a question. Is there any scholarship from Rosatom for students in Indonesia to study nuclear energy, especially in developing country such Indonesia? Is there Rosatom have scholarship like CSR? Thank you.
Please, Igor.
I see. Thank you. Well, there are some scholarships from our universities in Russia which study specialists for nuclear industry, and some of such scholarships are open for foreigners from other countries. So you'd better check our top nuclear universities, for example, Tomsk Polytechnic Institute, which have programs for nuclear energy. And we also at Rosatom Technical Academy organize conferences, organize special trainings under Train the Trainers program. And we can give some grants for traveling to Russia and for living and for studying. But these are short-term courses, short-term trainings for 2 weeks, and they're designed mainly for researchers, for scientists, not for students. So for achieving bachelor or master's degree, you better consult with universities.
Okay. Pak Arif Nurrahman, right now you are the student or already graduated from the universities, Pak Arif?
Sorry, could you repeat?
Yeah. Oh no, I asked the audience his position as the student, or right now already work for the government or enterprises. This is very important things, Igor. When we want to develop nuclear power plant in Indonesia, we prefer to use the proven technology. Proven technology means that the technology already, the power plant already in operation in your country, for example. But in other case, there are progress on the small modular reactors for the small island or a certain remote area. But unfortunately, there are only small numbers of technology on small modular reactors. In this case, how about Russia? Russia, it seems to me, you are focusing on the, well, KLT-40S, for example, the floating power plant, and you want to develop the on land such as reactors also. How can you convince us, for example, that this is proven technology, although maybe this is first of its kind? Because so many technology vendors come to us also. This is proven technology because we already have experience in the past, in 1960s and 1970s. But my definition of proven technology is different. If you develop one, then you operate in your country, then you can sell it to Indonesia. How about your opinion about that?
Well, thank you for interesting question. I can give you a case of Chukotka. Chukotka is a remote area in Russia in the very north. And back to the 70s, there was built, how we can call it right now, a small-scale nuclear power plant back to the 70s. And now the service life of this small-scale nuclear power plant comes to an end. So now it is replaced by newer floating NPP, as you probably know, since the end of 2019. So this small-scale floating NPP is the replacement for already existed small-scale NPP. It operates now it has operated for more than 2 years by now, and there seems to be no issues with safety or the stability. So by now we are proving that this floating NPP is reliable and it can be used at other locations. And for on land small-scale NPPs, there is also a project in Yakutia. Yakutia again is one of the remote areas in Russia, and a small-scale nuclear power plant there should be constructed by 2028. And that on land NPP will use the same technology which is used for floating nuclear power. So there is a great experience in small-scale nuclear power plants in Russia, and also they're based on some of them are based on our bigger nuclear power plants on our VVER technology, and that proves that they are reliable. And as we build more of such nuclear power plants in Russia, we assume that as a good source of energy.
Okay, thank you. Yeah, okay. Well, this is very interesting because when we talk about the SMR, there are not so many technology in the world. The quality for this is the floating power plant, and maybe the China HDRPM, and the other, for example, the United States of the technology of NuScale, for example, still under development or progress. That's why when I say to everyone in Indonesia, yes, SMR is very good, but we have to be careful about the what is the word of proven technology. I think it's very interesting to, if we know that Russia has already won for at least on the KLT for these the floating power plant. Bugeni, if you have any questions.
Yeah, thank you. I want to ask you, how about the price of electricity that you provide?
The price of electricity.
Well, thank you for the question. It is hard to answer, and it is hard to say the exact price because for different NPPs, the price of each electricity may differ in different locations, and it also depends on the market, on the current market situation inside the country. So in total, for Russia, electricity generated at nuclear power plants is one of the cheapest, because nuclear power plants are designed for 60 or even 80 years. So during this very long period, they can provide stable and cheap energy. For example, wind farms, wind turbines should be replaced every approximately 20 or 25 years, and gas or coal power plants should be modernized, should be equipped with new devices approximately every 30 or every 40 years. So because of the very long service life of nuclear power plants, their energy, the electricity they generate is cheaper than from other sources. But the exact price is different for any location.
Okay, so okay, thank you very much. Are there any Pak Indra Sakti, please, if you have any questions, please unmute yourself.
Okay, thank you, Professor Jarod. I want to ask about what ratio between private company and government company to establish nuclear power plant in Russia, and are there any law in Russia to regulate it? Thank you.
Could you repeat the beginning?
You have to repeat again. The ratio of the private sectors and the government.
Yes, to establish nuclear power plant in Russia. Are there any law in Russia to regulate it?
Well, Rosatom is the only operator of all our nuclear power plants, and Rosatom is the state corporation.
You are the state-owned company, isn't it, Rosatom?
So there are other private companies operating nuclear power plants in Russia.
Okay. Yeah.
Okay.
So Rosatom, the only one, operate the nuclear power plant, and Rosatom is also the state enterprises, isn't it? Okay.
Yes.
Yeah. Yeah. Jadi BUMN, Pak. Yeah. There is one question from Mr. Johnny Aritona. Has research and calculation been done that it is estimated that by 2060 there will be reduction of CO2 in Russia, and how is it calculated? I think the question is, how can you decide that 2060 is the target for net zero emission? Is there any calculation behind that decision? Maybe his question like that.
Okay, yes, there are a lot of calculations prepared by our ministries, for example, by our Ministry of Energy, but we cannot know these exact calculations because the calculations are not published to the public. So I cannot know what exactly the calculations, but I know some methodologies. There are several methods on how to calculate the real emissions, how to predict the future emissions, and such methods were applied when our state authorities decided that 2060 is the year of carbon neutrality.
Okay. Yeah, I think it's very difficult questions because behind that many aspects has been considered. There is one question from Mr. Pandu Santoso. In Russian perspective, is there any social impact when Russia build new nuclear power plant? Is there any, for example, the anti-nuclear movement or something like that?
In Russia, as well as in other countries, there are some organizations, there are some people who oppose nuclear energy, who protest, but they are the minority, and there are also public polls, like public surveys, asking people what they think about nuclear energy, what they think about nuclear power plants. And such surveys show that mostly the absolute majority of our population support nuclear energy. I myself was born in Kurchatov. It is the city with a nuclear power plant. So my parents and even my grandparents worked at a nuclear power plant, and there are also polls in such cities with nuclear power plants, and approximately 90 or 95% of people support nuclear energy.
Oh, it's very high. Okay, very high. Okay. Okay, thank you. I think in Indonesia, we already done some public survey that in 2016, the public survey shows in national survey with the 4,000 respondents, about more than 77% of the respondents pro-nuclear. How about in Russia? Is there any national public survey on nuclear energy?
I guess so, but I don't remember the last survey or the result. So unfortunately, I cannot answer it right now.
Okay, thank you. Bugeni, is there another question?
Okay, thank you, Pak Jarod. Igor, your presentation is very interesting one to us. I want to know about the current status of your nuclear technology development, especially regarding with the NPP that not only produce electricity but also combine with the non-electric application industry. So how is the current status of the Russia about that, related with that kind of technology? Thank you.
Thank you. Yes, we can use our NPPs for other purposes other than electricity. In cities around nuclear power plants, such cities use thermal energy produced by NPPs for heating our houses, because in Russia we have very cold seasons, very cold winters. So this thermal energy, so just hot water, is a great solution for heating the houses. And also in some reactors at some NPPs, we can produce some, for example, medical equipment, some special radioisotopes for medical purposes, for medical applications. So there are several ways on how to use the energy and how to use this process inside the reactor, and they are indeed applied at our NPPs.
And how about the hydrogen production process? I mean, the current status. Do you have the commercial facility regarding with that one?
Thank you for this hydrogen question. Yes, we have Kola NPP. It is in the north of our country, and currently it has some excess energy. And there are plans, and Rosatom does develop such programs on using this energy from this Kola NPP for hydrogen production. The technology is electrolyzers. So the specialists of this NPP will use the electricity for electrolyzing the water, the clean water, and we have hydrogen and oxygen by this process. And as far as I remember, this electrolyzer equipment will be installed in 2024 or 2025. So this NPP will produce hydrogen.
Oh, really? So it
Yes.
will be operated on 2025?
So there is already an NPP, and they want to add electrolyzers, special equipment for producing hydrogen. Yes, and it will be installed by 2025. Yes.
And then coupled with the NPP? I mean, the hydrogen production facility is coupled or combined directly with the NPP?
I'm afraid I don't quite understand, but yes, it will be at the same site, like a special facility, a special building for hydrogen production at the territory of this NPP.
Okay, thank you.
Okay, thank you, Bugeni. There is one question from Pak Sulistyo Anjasmoro. I think this question is very typical Indonesian questions, because we conduct so many surveys that the results, the pro-nuclear percentage is much higher than the anti-nuclear, but still no decision about the nuclear energy program in Indonesia. his question is, how are the effort of the Russian government at the first time to make all people comfort and believe that the nuclear energy, nuclear technology is safe? How can you convince to the public so this nuclear technology is safe at the first time? So maybe you have to.
Well, the first nuclear power plant in Russia was constructed in 1954, so more than 60 years ago. And there were no public polls or public service back to that time, back to 60 years ago. And that was a small scale, very small scale NPP, mostly even experimental, just to prove that it is possible to produce energy by NPPs and that this process will be safe. So as our nuclear programs started more than 60 years ago, the public already know that nuclear technologies are safe. So this question is not the issue for our right now. And back to that time, people know little about the nuclear energy. So there was almost no need in public.
Okay. I think this is my personal opinion. Maybe 60 years ago, this situation was very different with right now situation at that time. Maybe Soviet Union era. Maybe there is no option. This is my own personal opinion. So the government decided to build nuclear power plant. There is no objection from the public. Maybe I think I don't know. Maybe the situation. I think Pak Sulistyo and Jasmoro, I think we could not compare between the Russia and Indonesia about their history with us. Right now, we have to convince to our government, to our stakeholders, and of course to the public, this is very safe. I think the different histories is very big between us and Russia. Yeah, I think one question from Pak Ronald Kultam. How much the biggest power of nuclear power plant in Russia is right now? Maybe his question is the biggest power in one power plant, maybe 1,400 or megawatt or something like that. The biggest one is, maybe you know how to answer this kind of questions. There are a lot of type of power plant, and maybe the biggest power around.
I see. So actually, the biggest nuclear power plant in terms of installed capacity may change every month. So I may give you a wrong answer, but as far as I remember, Leningrad NPP currently the biggest in terms of installed capacity, and its installed capacity is 4,000 and approximately 400 megawatts. Many of our NPPs, of our large-scale NPPs, have installed capacity of approximately 4,000 megawatts. So several NPPs have such capacity.
Okay, thank you.
It's just above 4,000 megawatts.
Okay. And again, Pandu Santoso asked about, I don't know for sure how to answer because I don't know. How come Russia reduced the flaring system? I don't know the flaring system in the future. Maybe Pak Pandu Santoso would like you. I would like you to say something to explain your question, please, Pak Pandu.
Assalamualaikum, Pak Jarod.
Oh, monggo.
Yes, Igor. This is question for me. Kindly curiosity of that you utilize the gas is about 35 to 40% up. so many utilized gas, and then so many probably the gas plant, and the gas plant is outcoming is so many flaring. So how come you reduce the flaring?
What is flaring? Excuse me.
Flaring when the gas, the upside gas is not utilized, then you flaring to atmosphere.
I guess I understand what you say. I'm not very involved in gas industry and their technologies, but as far as I know, they capture this flaring gas, and they also
inject into the well, injected into the well.
I think Pak Pandu, you're expert on the gas exploration, I think. Yeah, Pak Pandu.
Yeah, I'm came from the Pertamina EP.
Oh, okay.
So I'm asking that you utilizing gas, but so many percentage in the future. So how come you reduce to zero emission? This is my basic question.
I know that there are not just for capturing gases from gas-powered power plants, but most of them are expensive right now. And yeah, there are also projects for capturing these gases and digging it inside the ground, inside the used wells and deposits for oil. But the exact technologies and the exact process, I'm sorry, but I cannot answer it.
Okay.
Okay. Is this one more question? Is it when audience asking about the taxes? Right now, if you flaring many things, then the tax is quite big. This is my understanding.
Yes. All right.
Thank you. Terima
Thank
kasih,
you, Pak Igor. Terima kasih, Pak Wisnu.
Terima kasih. Thank you. My question is about the Russian nuclear energy program. It seems to me you will increase the percentage of nuclear energy from 20% into 25% in 2060. Well, do you think it's not so that the increase is so small? Maybe.
Russia is a huge country, and in different regions there are different demands for energy. So this is why we cannot build. There will be no sense in building a large-scale NPP in areas where no one lives and where is no economic activity. The regions with the most economic activities, with the most populations, there are already quite a number of NPPs, and there might be not enough free land to build in a new NPP. So this is why, in our case, it will be hard to increase this share to bigger numbers.
Okay, maybe although the percentage is 25, but I think because the projection of at that time may be bigger than at the moment, how many gigawatt I don't know, but that the quantity of nuclear power plant is much bigger than present situation, I guess.
Yes.
Yeah. Okay. So this is another questions about the earthquake, about the similarity with Indonesia. Maybe this is good for audience to know. Well, how can you locate the nuclear power plant? Is there any nuclear power plant on the area that have a high potential of earthquakes?
First, in Russia we have a wide variety of regulatory documents, a wide variety of requirements for NPPs, and inside these requirements, there is also one that nuclear power plants should sustain the earthquakes, should sustain 8 scale earthquakes according to MSK 64 scale. So first, our NPPs are designed to sustain even severe earthquakes. And concerning the locations, currently there are no NPPs in Russia located near such areas with earthquakes. Maybe with the one exception of Chukotka, I mentioned that power plant before, and that's this region is affected by earthquakes, but the severity and the frequency of earthquakes there is very low. So yeah, this is it.
Okay, well, this is a very important question. Usually people of anti-nuclear movement always say, look, Indonesia is a earthquakes country, so we live on the ring of fire. But I always say, look, we can choose an area or areas that potential earthquake is very low. And of course, I always use the example of maybe in Japan, maybe in other countries also. They build the technology, the nuclear power plant on the location that maybe the percentage of earthquake is rather higher than us. The technology can solve this problem. But anyway, we always used to find the location that, like in Kalimantan Island, that the probability of the earthquake is very low. Yeah, thank you.
I would like to add that for modern NPPs, we use so many concrete so that the building, the reactor may sustain almost everything, almost any disasters possible. So this is why it is safe to build NPPs even in the areas affected by earthquakes or volcanic activities.
Oh, okay. Well, this is another question about Rosatom is very active internationally to export the nuclear power plant in Bangladesh, in Turkey, Belarus, and other countries. My question is about the cost. Is there any general or common costs about this kind of nuclear power plant, the similarity, or is this site-specific that consider the cost of the constructions of nuclear power plant? For example, comparison between Bangladesh, Turkey, and Belarus, for example.
Thank you for question. Most of the numbers about the costs, about the economic expenditures on NPP are commercial secrets, so we may not know the exact numbers, but we may know the sum of the contracts. So when Rosatom builds an NPP in Turkey, there is a special contract, and the same situation with Bangladesh, and in such contracts their price is specified. If I'm not mistaken, for Bangladesh, for 1,200 reactors, each costs approximately $5 or $6 billion. Okay. And for Turkey, Rosatom builds nuclear power plants with 4 reactors, and the contract is, if I'm not mistaken, $20 billion or 25, but it's better to consult the contract.
Okay, well, this is very interesting because as far I learned that for Turkey, there is one scenario to use the scenario of build, operation, and own, as far as I know. So I think the company that established by Rosatom and local company maybe have a new company, they own the nuclear power plant and sell the electricity to the Turkish utility company. So this is similar with our previous long time ago. Indonesia have already had a scenario: build, operation, and transfer. Maybe the vendors will build for us the nuclear power plant. They operate for 15 years, for example, and after that transfer to Indonesian government or Indonesian utility company. But still, we are consider many scenarios on that. Okay, thank you. Is there any question from the audience, please?
We have the time for the last question because our time, if I'm not mistaken, is exceeded.
Yes.
And for other questions,
okay,
you may send them by email and answer them later.
Yeah, okay. One of the challenges to build the nuclear power plant is the time. It takes maybe more than 10 years. That's why the government of Indonesia always ask me, for example, how long it takes to build the nuclear power plant. Maybe for construction in 48 months, but there are a lot of steps for the licensing. Do you think in the future there will be shortening of the time to build the nuclear power plant? How was the Russian experience about this time of the nuclear energy program?
Thank you for question. Rosatom here has an advantage over some other suppliers of NPPs because Rosatom builds NPPs faster than other vendors. For example, a new NPP in Finland, constructed by French companies, is at the stage of construction for more than 10 years. And in case of Rosatom NPPs, we built an NPP in Bangladesh. The construction started, so this first started back to 2017, and the first unit will be completed in 2023. So the approximate time requirement is 6
years?
7 years, yes, for unit. And this construction includes not only the nuclear power plant itself, but also the development of needed infrastructure. So the development of power lines, power grid, the development of transport facilities for transporting fuel. So all these issues are covered by 6 or 7 years right now.
Yeah.
And new units which are constructed in Russia, the time requirement is approximately 5 to 6 years because currently we build new units at the site of previous nuclear power plants. So there is already some infrastructure, and that's why we need less time for building new units at the previous sites.
Okay, this is very good news. Ini Bapak Ibu sekalian, I will say it in bahasa Indonesia. Allow me to explain to everyone. Contoh Bangladesh ini contoh yang bagus untuk membangun PLTN yang membutuhkan waktu, kemungkinan ketika pertama dibangun tahun 2017 kemungkinan akan beroperasi tahun 2023. Jadi 6 tahun. Dan 6 tahun itu sesuatu yang menurut saya suatu yang sangat cepat. Moga-moga itu terjadi. I think it's very good news because internationally we learn from the Finland case. It takes maybe, well, it takes more than 10 years And of course, when we learn from the UEA, when they built in 2009 and they operate the nuclear power plant in 2021. That's why this Bangladesh is a good news for us. There is an example that less than 10 years. Why I say this is very important? Because one cabinets in our governments, they have a time for 5 years, the president, for example, then it can be extended another 5 years, 10 years. If we have an example about this Bangladesh case, so we can show to our government, oh, look, this is 6 years. That's okay. Thank you. How about the Belarus? Belarus, how many years? In the case of Belarus?
It is almost the same. So
Okay.
5 to 6 years for the first unit to start.
Okay. Okay. One person, Mr. Ismail Ibrahim, say 6 years is too long. Okay. Anyway, this is for us or nuclear community. It's very short.
Well, for example, for wind farms, we need approximately 2 years. So we spend the first year on analyzing the movement of air, and we spend the next year for constructing these wind turbines themselves. So for many power plants, they need several years to construct. So, and 6 years compared to 2 years, so even 1 year, if we build a new power plant very fast, it is bigger, but it's not so huge.
Okay. Okay. Thank you. Yeah. Well, there are more than 280 participants in Zoom and more than 50 in YouTube, because your presentation is very interesting. So when we
I have another question.
Please, Ugeni.
Okay, thank you so much for the opportunities. Igor, I want to ask you about the duration of constructing the NPP. You said that in your country, and maybe hopefully in Bangladesh, it may take around only 6 years or something like that. Yeah, I hope the best for the Bangladesh. But I want to ask you about what is the most spectacles on constructing NPP related with the construction duration? Is the most spectacles. If you build, maybe if the Russia build the NPP in Indonesia, can you predict what is the most spectacles that can delay the constructing duration?
I see. So there are several stages during NPP construction. Yes, and it starts with analyzing the energy demands in this area and in the country. It starts with analyzing local conditions. So we need to choose the best location. So a lot of land should be checked for the seismic activity, for some groundwater resources, for a lot of things. And this process requires several years for analyzing and for preparing a report. And the other obstacle is the preparation of personnel. So in some cases, an NPP had to be started few months later than it is expected because there was a lack of qualified personnel. So issues of training specialists or preparing specialists should be also considered as early as possible, because they may, if they are ignored, they may delay the start of that NPP. So I would say these are the main obstacles for the duration.
Okay. Oh yeah. Yeah, I have another question, Pak Jarod.
Please.
Okay. Pak Jarod already mentioned about the earthquake potential. Yeah, as you know, that Russia and Indonesia is very different. Indonesia has a very high numbers of earthquake. regarding to your NPP design, of course, I'm sure that your design already safe enough, yeah. But if the Russian technology, NPP technology, if you implement in Indonesia, do you need some revised assessment again regarding with the seismic aspect in Indonesia?
Well, for Indonesia, yes, so we had to invite specialists, geologists, for example, and other scientists to analyze the local condition, analyze the local peculiarities of Indonesian earthquake situation and the volcanic activities. So it may affect somehow the design of an NPP, but it will be considered and it can be easily tackled if we analyze the local conditions at the very beginning. So changes are possible, and there is nothing very hard to mitigate some peculiarities of earthquake frequencies in Indonesia.
Okay.
So you will reassess again the design, and then imply if you will be implied to Indonesia.
Not the whole design, some peculiarities about the construction, about the buildings. So
Okay.
all changes.
Okay. Yeah. Thank you.
Okay. This is the last question. I think from me, some people always wondering, what should we do with the radioactive waste? As far as we know, there is no disposal facility in the world dealing with the high-level waste or spent fuel waste. Only maybe in 2023, the Finland will operate their facility. How about Russia on that?
Well, for spent fuel, there are projects for closed fuel cycle. So spent fuel may be reused again. So it's one of the issues. So this high-level radioactive waste. And for the rest of high-level radioactive waste, well, actually, the amount of this high-level radioactive waste is not so big, and there is no better solution than just to dispose of it, like in some special storage facilities or deep underground. But for the majority of other radioactive waste, we can and we do wait for several times, and the radioactivity decays, and then these wastes are not so dangerous as they used to be. So for some of high-level radioactive waste and for spent nuclear fuel, we can reprocess it. For the rest, is one option is storage.
Okay, thank you. So I think Igor has already explained about the radioactive waste, because some of you maybe ask many things about radioactive waste. The Russia have a system, closed fuel cycle, so they reprocess again the spent fuel to put the uranium and plutonium to be operated again as the fuel for the other reactors. That's why they produce high-level waste with the volume is very small, isn't it, Igor? So they will find the location maybe in the futures, how to dispose or where to dispose this very small volume of radioactive waste, high-level radioactive waste. Because of some of us, have an image that this waste is just like a common waste, industrial waste, or something. Something that we always find in our daily life. This is the waste. So anyway, thank you very much.
Pak Jarod, it is very interesting your statement, because Russia do some reprocessing, spent fuel reprocessing. So if we build the Russian NPP in Indonesia, is there any possibility the spent fuel will be resent again to your country?
Yes, there
Okay.
is a possibility.
Yeah,
And
okay.
and used at the same nuclear power plant again.
Okay, thank you.
Okay. Our experience with our reserve reactors, when we bought the uranium from a certain country, then we have some kind of understanding that after we use this uranium as a spent fuel, we send it back to that country, repatriations, using the repatriation. So maybe the Dr. Geni question is there any possibility if we have a contract with the Russian vendors, with the Rosatom, to build the nuclear power plant in Indonesia, then we can send it back, the spent fuel, to Russia? But maybe more expensive than would be.
Hard to predict, but it is possible.
Okay.
For economic properties, we cannot right now.
Okay. I think it's very interesting to know about this scenario. Bapak Ibu sekalian, ini penting. Kadang-kadang ada orang yang bertanya, itu limbahnya bahan bakar nuklir bekasnya mau dikirim kemana? Rusia mungkin menawarkan, ya kirim ke kami saja. Tapi kalau saya pakai bahasa Indonesia ini, yang mending kita simpen aja sendiri, kan itu masih bisa kita manfaatkan suatu saat kelak. Yeah. Anyway, thank you very much, Igor, for your presentations. I think the audience with the numbers more than 300 totally, Zoom and YouTube. I think your presentation is very, very perfect and very interesting. You saw us using the actual data about the climate change, about nuclear energy advance, and also the comparison between the two countries, the energy situation in these two countries. We should learn from your side. Although we have a different situation, you are a rich country on nuclear, on the energy resources, while we are limited with coal, with gas and others. Hopefully, in the future, the government of Indonesia realize nuclear energy is one solution to solve the climate change problem. We will reach the target of net zero emission. One solution, one option is using nuclear energy. Although the government of Indonesia say presently we will operate the nuclear power plant in 2045. We expect not 2045, maybe 2035, maybe. But anyway, we learned a lot today. Hopefully, the cooperation between Russia and Indonesia will stronger and stronger. Thank you very much, Igor.
Thank you. Thank you, dear participants.
Yeah,
Thank you so much, Igor.
Thank you. Ya. Bapak Ibu sekalian, jadi kita akan sudah selesai mengadakan webinar hari ini. Yang belum mengisi absensi, silahkan mengisi absensi dengan menggunakan QR Code 2 ini. Kalau belum sempat membuka linknya yang sudah disampaikan oleh Ibu Susi dari HIMNI. Kebetulan memang chatnya ini baru bermasalah ini, Bapak Ibu sekalian. Jadi waktu tadi juga saya harus mencari-cari bagaimana mendapatkan lebih mudah pertanyaan dari Bapak Ibu sekalian. Pelajaran yang penting dari Rusia adalah Rusia terus mengalami evolusi di bidang energi. Meskipun punya banyak gas nomor 1, cadangan batu bara nomor 2 di dunia, minyaknya nomor 8 cadangannya di dunia, tapi nuklir diberikan peran yang signifikan. Tahun 2025, 25% naik 20% dari situasi saat ini. 25% itu berarti dia akan punya banyak PLTN, karena pada tahun 2060 pasti demand terhadap energi sangat besar. Nah, itu kira-kira kita akan ketemu Kamis depan dengan topik yang berbeda. Tadi Bu Geni sudah menanyakan masalah teknologi hidrogen. Kami akan mengundang narasumber dari BPPT untuk menyampaikan apa tantangan teknologi hidrogen di Indonesia, bagaimana implementasinya dan potensinya untuk dimanfaatkannya nuklir sebagai salah satu tool untuk produksi hidrogen. Terima kasih, kita ketemu Kamis depan. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih. Terima kasih Bapak Ibu.
Warahmatullahi wabarakatuh.
Mohon maaf itu chatnya tadi bermasalah ya.
Terima kasih Pak Jarot. Selamat sore.
Matur nuwun Pak Jarot.
Terima kasih Pak Wisnu.
Ya, sama-sama Pak Markus.
Terima kasih Pak.
Mari.
Terima kasih Profesor.
Yes,
siap. Di Kepulauan Riau. Siap Profesor. Siap bergabung.
Sukses.
Angkatan 22.
Ya. Semangat Indonesia.
Terima kasih Pak Jarot.
Sami-sami Bu Enda. Terima kasih juga.
Terima kasih Pak Jarot.
Sama-sama. Gimana Pak Markus?
Bu Geni juga, terima kasih.
Oh, sama-sama Pak Markus. Sehat ya Pak.
Terima kasih Pak.
Terima kasih.
Terima kasih.
Ya, terima kasih. Sebentar lagi saya akan tutup Zoom-nya. Sekali lagi kita ketemu Kamis depan.
Terima kasih Pak Jarot.
Sami-sami Bu Ari.
Betul Bu Geni.
Selamat nuwun Mbak. Salam sehat semuanya Bapak dan Ibu.
Mari.
Terima kasih Prof. Jarot.
Mari sama-sama Pak.
Terima kasih Prof. Jarot, Bu Geni.
Iya,
Selamat
sama-sama.
nuwun.